Hello, 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 hello. Can you hear? Hello.
Yes, we can hear you.
Thank you. So where are my hellos? What's going on here? Hello, 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 hello. Thank you. Thank you, Fatima.
Hello.
Thank you, Marina. Wait,
Hello.
hello, hello. Thank you. Now we're talking. Wait, Fatima, Marina. Oh, yes. Okay. Thank you, Fatima. Thank you, Marina. Thank you. Hey, all I get is a hey. No, okay, okay. Okay. I can see where we are today. It's a late day. All right. Hello. Good afternoon, Sylvie. Thank you. Hello, Marina. Good afternoon, Sylvie. Hey, Ashton. Hello, Ashley. Thank you. Hello, Abigail. Hello, Jake. Okay. Hello, and Isabella's coming in. iPhone is go. Oh, and there goes my board. Okay. I'm going to tell you right now. Okay, wait. Losing my board again. Thank you for coming. I will tell you right now, I've heard many things about your experience Monday. I've heard things from some of you. I've heard things from some of Mercedes. I can certainly tell you right now that for good or for bad, the main focus of almost everything that we're going to be doing today is helping one another. It's having me help you and there it goes again. Almost all of what we're going to be doing today, whether it's interesting or not, is making sure we're all solid with this practice exam, i.e. making sure we're all solid for the actual exam. That is the goal for today. Hopefully we can keep things interesting, but put another way, any actual physics question that anybody has, hello, good to see you. I hear you're, wait, you're roommates with, no. Wait, are you roommates with Brooke? Okay, sorry. Anyway, whatever. Did I just hear that? Anyway, hopefully hello. Oh, and that's iPhone is you. Wait, no, wait. Okay, okay. Good afternoon. Good afternoon. All right, I'm already babbling. We're already in, and I'm already a mess. The goal for today is that any and all questions that ever got raised about your practice midterm should get addressed today. I mean, ideally by me, I think. We should have a full coverage and full hello, iPhone, understanding of your practice midterm by the end of today, even if that ends up being sometimes boring. We want to be prepared by the end of today to take your midterm. I'm not saying you're taking your midterm by the end of today, but we as a group want to be prepared to do that. So that's what today is about. And I think it's good that you had the experience first of trying it without help. So I'm not saying I'm going to walk through every single bit, but I'm saying I'm going to walk through some, and I'm going to try to address anything you ask. And so good afternoon, Sulady, and hello, Kayla, and hello, Jake. And I think that's it. And just so, okay. Okay. So give me one more second to fix this board. Oh my God, really?
So you know how homework is worth somewhere between like 15 to 30 points? How many points would this exam be worth?
Okay. That's a good question. So the simple answer to your question, I mean, the straightforward answer to your question is an exam is worth 100 points. Now, how the points work, maybe I should remind you in a minute or re-explain, like they go to different buckets in a way, those points and these points. But yes, it will be worth 100 points. I can answer all those kind of questions today. Hang on. But yeah, the simple answer to your question is an exam is worth 100 points. I mean, that's the straightforward answer to your question. I think that probably means that in a minute, I should remind you like where all the points go and how that works again in a second. I think I should. But yeah, the exam is 100 points.
Thank you.
Oh, okay. Thank you. Thank you. So hold on. Okay, so this is our board. So, and there is, okay. Pardon me for a second though. Apparently there's something going on my side. Just, I'm going to mute for a second. I'm going to step away. Good point. Thank you. Sorry about that. Was I muted the whole time? Sorry. Yeah. Okay. I was muted. All right. Thank you. Sorry. I'm just going to say, I'm going to switch screens now. I mean, I'm going to screen share the exam itself, the practice exam itself. And this is the structure of the class today. I'm going to start walking through in my way, saying what comes to my mind that I think is helpful as I go. But you're going to stop me and redirect me. Like, honestly, like I'm driving, you're steering. I'm going to walk through the exam. But if I start getting to a place where you guys think you're clear or whatever, you could say, no, go on. Like, we don't need to see that. But if we get to a place where you need to see something, you're going to tell me. But without input from you, I'm just going to sort of go through it. And I can tell you right now, if you don't give me input, I don't mean this as a threat, but if I just start walking through and like people don't redirect me or start giving me organically feedback about like what happens in the room on Monday or where you need this or what, if you just leave it to me, as you all know, what's going to happen is I'm going to start going down a rabbit hole and getting really, really elaborate about like question 1, and I'm never going to get to question 4 or something like that, right? So you don't want to leave it to me. We all know that. But we're going to use the exam as like the structure of going through today's class. So let me just screen share. Let me try to. Just lost it. Sorry. Sorry, I just lost it. Okay, here we go. Okay. 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 So I'm assuming that like I assume this was your, yeah. But stop me if this does. And I would suggest that you have yours in front of you too. So I suggest that you have yours, and by which I mean you should have the questions and whatever answers you wrote down. I mean, I don't need to tell you that, but whatever answers you wrote down in the first half of last Monday, I'm gonna start by reminding you or pleading with you to understand on Marina's question. The way an exam works in this physics class is what you're going to get an exam that looks very much like this. I'm going to point out where it's going to be different and where it's not, but it's going to be very much like this. It's going to be shorter. Like it won't be longer than this. It will be, and you won't see anything on your exam that's not on this. Like that, I can tell you. There won't be any surprise, other new thing or something like that. Your exam will be taken from this, but it will be not as long as this. And you might possibly have choices in yours, like somewhere it might be like do this and this, but then choose to do that or something, right? But your exam will be no longer than this one, and in fact shorter. It will look like this. It'll have similar formatting and all of that. What you'll do, and I can't emphasize this enough, you're going to treat it the way you did homework. The homeworks are like practice for this, in that you're going to get separate blank pieces of paper for yourself. You're going to write out your responses in those separate white pieces of paper as though they were blue books, okay? You are going to label each question like question 1, and then start your work and stuff. Question 2, you are, and I know I sound mad right now. I'm not mad about anything. I'm just like, I get intense around test times and I just want to make sure this is clear, and it's been a long day. But and I know there's confusion about this sometimes. You, on the one hand, there's also, let me also warn you, these kind of things when it comes to exams, this is where I'm a little bit less loose than in other places. And it's a little bit hard to predict where I would be strict and where I wouldn't be. So one thing I'm strict about, as weird as this is on your separate pieces of blank paper where you're going to work out your solutions, you're not going to copy and paste my questions or anything like that. But you're going to use your words in your way to absolutely make it clear what the question is for each question. Like, first of all, you're going to label it like question 1, but then you, in your 5-step method of solving problems, the first thing you're going to do is you're going to draw a picture, whether I gave you one or not, which is kind of what this whole thing is trying to encourage you to do. You're going to provide some kind of picture, then you're going to say what the question is, kind of in your words, and you're going to make it clear to me that you know what the question is, and you're going to make it clear to me what question it is that I'm supposed to be grading. And then you're going to go through steps 3, 4, 5, whatever of the problem solving method, assuming it's applicable, and you're going to show your work and then you're going to circle your final answer. And then you're going to go on to the next question, et cetera, et cetera. At the end of the day, you will have all these blank pieces of white paper that have all your responses on them. And your goal in those responses is to give me a self-sufficient document, like a document that can be read by itself, where anybody who knows any physics, even if they're not in this class, could follow what you're trying to do and see what question you're trying to answer, and then your work, and then that you answered the question and knew it was your answer because you circled it, right? So, and put another way, you're giving me a document that I could grade. Like, your test is, could he grade this without having to look at anything else besides my work? Does all my work provide every information that he needs to actually assess the quality of my work? You want to make it as easy on me as possible that's what you want to do. So that's the first thing. I just want to make clear, don't try to do your answers on these questions. Please don't. Okay. So you get this. Sorry, I don't know why that's doing that. Blah, 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 blah. All right. So, right. So you look at a large circle, you have a piece of string, you wrap the string around the circle. It fits fully. So all of this words right here is trying to say, just to be clear, you're imagining now a piece of string that represents the full circumference of a circle. And one of the reasons it walked you through all of these words that might have been cheesy or annoying or whatever, it's trying to emphasize to you, it's really trying to emphasize that a circumference, even though it exists in 2-dimensional space, even though a circumference is a round thing that occupies 2 dimensions of space, it is actually a 1-dimensional length. Circumference is measured in meters, not square meters or something like that, right? So it's just asking you to picture all this so that you can really have it in your mind that whenever we talk about circumference or portions of a circumference, like arc length, we are literally talking about lengths. They just happen to be bent. They happen to be warped and curved, but they are lengths. They are numbers of centimeters and meters. That's what this is trying to get you to see in a way. So you do all that. All right, so now you have a circle that has a radius of 10 feet. Now I'm not going to go through every single one of these. I'm just going to try to give you the overview of this. I'm going to go through a couple until we all see that we get the pattern. And then, okay. So you have a circle, you find the radius is 10 feet. I'll just ask you now, just so I can stop talking for a minute. If the radius is 10 feet, what's the answer to question 1A, the length of the entire string of one circumference? So I'm asking you, and again, partly just so I can stop talking so much and so we can move on. What did you get for 1A for the length of the entire string for one circumference? Oh, there is stuff in the chat. Good. Thank you. Okay. Oh, am I muted still? Wait. Wow. Okay. So I'm actually getting a lot of different answers in the chat. That's interesting. Okay. 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 This is worth talking about then, it sounds like. Okay. And when I said chat, I meant either, direct chat or public is fine either way. And I applaud all of you who are going in either chat. And remember, you can always submit these for points. Let me say, I see a lot of answers. There's a lot of answers in the direct chat, and a lot of them are different. So it seems like this is worth talking about for a minute, but I'll also say, to cut to the chase, I will also say, to cut to the chase, that the one answer that is in the public chat, I do think is correct. I mean, I do agree with, and that's not to shame anybody else, obviously. Let me say a couple of quick things. In the instructions in this exam right now, it's trying to make clear to you, like, it's saying that sometimes in this exam, we're really going to think of pi as pi. And sometimes we're going to write it as like 3.14. And sometimes even in our head, we're just going to think of it as 3, actually. Okay, there's advantages and disadvantages of both. When we write pi as pi, we're being exact. We are being exact. We write as pi, where the symbol stands for like that whole infinitely repeating non-patterned set of digits. But when we write it as pi, the disadvantage is, first of all, many of us find that very abstract. We can't relate to what it is we're talking about. We can't even picture it. And more to the point, scientifically, when we write it as pi, we can't imagine that as a measurement. You can't literally find pi on a ruler. So mathematicians often tend, when we're thinking strictly mathematically, we tend to write it as pi. When we're thinking more in a scientific context or trying to picture and measure and intuit things, we tend to write it as some kind of number. Now it happens, so you have to be careful about that. And sometimes that's a very tricky judgment call. In this exam, we try to tell you when to do which one and when to do which one. We try. And by the way, the other reason we're doing, why you did this practice, just so you know, again, sorry, this exam is a rough draft for your actual exam, both for you and for me. You had like a rough draft experience on it on Monday. We're going to have a little rough draft experience going through together right now. The idea is that by the time you get to the actual thing, it's very nice and clean and final for you. But that's also the idea for me. We're also doing this all together in case if we find things that are too confusing or are errors or are problematic, then it gives me time to get rid of them before, or change them before your exam. So I hope we're all like in this together here, and like, I'm trying to help you get this exam nailed, but you're also trying to help me make sure that it's fair and all that. So there's a lot of words in this exam, just like I use a lot of words, because what we're trying, well, partly because I'm just imperfect, but partly we're trying to break down all these abstract mathematical things and really show you how they actually do relate step by step to ways that we all think. Sometimes it gets very overly wordy, like right now. But one of the words that's trying to tell you in this thing is it's trying to say, sometimes we're going to specify whether we want your answers in pi, written as pi, or as a number. When we specify, follow our specification, since it is an exam. So the truth is, first of all, one thing I like about what Jake's answer is in the chat here is he did give an answer that is written in terms of pi. Like that is, some of the answers in the chat might have actually sort of been right, actually, which I'm impressed, but just want to warn you that like, it's asking you for an answer that has pi. It says you're encouraged to write pi instead of 3.14, et cetera, et cetera. So we kind of want an answer that has a pi in it here. Now, it's also asking, though, it is asking for a length in feet. So what, I don't know if I should switch screens or not. I can do it in the chat. So the key thing that Jake is doing, and the key thing that this whole thing is based on, oh, he actually put a pi in there. That's so clever. How did he do that? Oh, I know. That's very clever. Hold on. Okay. The key thing, you might want to look in the chat right now, because I'm trying not to switch screens. The key thing that Jake is basing his answer on, and is actually the key thing of like, weirdly, like half this test this is all based on the idea that the circumference of a circle is 2 pi times the radius of a circle, always, that's what pi really means. It's the ratio of this to this for any circle of any size. So what he's just doing is he's plugging in 10 for r. He's plugging in 10 feet for r. So I'm doing this in the chat so I don't switch screens. Okay, so if you look in the chat, I mean, and also obviously I encourage Jake to stop me if I'm like misunderstanding what his thinking is or misrepresenting it. But what he's saying is he plugged in 10 feet for R, he multiplied by 2 pi until he got 20 pi feet. Now I know all of you can do, like, you might, some of you might be thinking, oh, that's all he wanted, or Yaverbaum wanted there. Well, in a way, yes, that's all I wanted. But why am I even asking this? We're trying right from the get-go to get you to see that that circumference is measured in feet, and circumference is some multiple of pi always. So you can have some number of pi feet. It's hard to picture on a meter stick, but there's no contradiction. Basically, we're trying to get you to see that pi itself, part of what we're trying to get you to see is that pi itself is just a number. Pi doesn't automatically only measure radians or something like that. And radians don't automatically only have to be measured in multiples of pi. Pi is just a number. What the number is the ratio of, it's how much it, the whole discovery of pi is just that. No matter what circle you ever take, if you compare a string that goes all the way around that circle to a string that goes straight across the circle, the string that goes all the way around is always exactly a certain number of times bigger than the string that goes straight across. This is the discovery, that no matter how big a circle is, going to go around the full circle, you have to go a little bit more than 3 times as far as you go to go straight across. That's a discovery. It's not obvious. We're not saying it's obvious at all. I would have never thought of that. Forget about what the number is. I would have never known that no matter how big a circle is, it's all a string that goes around the whole circle is always exactly the same number times bigger than the string that goes across. But it turns out that it is. And the number of times is a little bit more than 3. It's just a little bit more than 3. That little bit makes it a very kind of strange, irrational number. But that's all it is. It's just an unusual number. Don't get hung up on that. It's a number that's a little bit more than 3. So if we're being exact about it, the circumference of this string is 2 pi times the radius. The radius is 10 feet. So it's 2 pi times 10 feet. So it's 20 pi feet. Basically, I'm agreeing with Jake's answer. I'm not trying to be weird. Apparently, I'm a little bit, I'll calm down at some point soon. But can I go on? Is everybody clear? But I guess since there were other answers in the chat, and I am pleased that there were other answers in the chat, but since there were other answers, are we actually clear with the correct answer? Like, can I get a thank you. And is that you, Jen? I can't even see. It's like so dark. Is that you? Okay. Thank you though. Thank you. Oh, wow. Cool. Okay. So, okay. Thank you. Okay. Cool. I agree. Oh, okay. Thank you for your honesty, direct chat person. Okay. That's totally, you should totally, direct chat person who said, I agree and I understand it now. Great. That really helps me a lot. You can see my heart rate is going down. You should totally submit that for points of participation. Also, you, direct chat person, and other direct chat person, and Marina can later remind me to explain to you all where all those points are going and how that will help your grade and all that. So great. Thank you for your on. All right. So I'm going to go on. Now I'm going to go a little bit faster. If we actually get that, you could see the questions become sort of a pattern now. They're trying to like drill in or drill down and exercise you so you can visualize all this. So like if the answer to the first one, if Jake said it was 20 pi feet, I've almost forgotten what he said. Yeah, 20 pi feet. Then, okay, the answer to the next one is going to be 10 pi feet. Okay. The answer to the next one's going to be 5 pi feet. Everybody with me so far? Wait, thumbs up if you're with me so far. Like, so answer B, because I can't write these because it's on the, but okay, thank you, Maria. Okay, I assume that means you're with me. So, okay, cool. Okay, so B is 5 pi feet.
Yeah, I accidentally put the hand instead of the thumb because usually you say hand, but then I was like, oh, she meant the thumbs up.
Okay, no, cool. Well, actually, to tell you that, no, thank you. Yes, in your case, I meant pause up actually. Oh, okay. No, yes, okay, because of the dog, right? Okay, I'm not saying your dog. I'm saying
Well,
the
in my case, yeah, it's pause up.
okay. Okay, right. All right. So cool. Thank you for the participation. All right. So the entire string is 20 pi feet. The next string is 10 pi feet. The next string is 5 pi feet. Now I'm going to pause here for a second. Like, why am I doing this? I'm trying to get you to picture that what we're looking at here is we're looking at portions of the edge of a circle. We're looking at, we're just trying to visualize or play with on the piece of paper. We're trying to just visualize, oh, what if we made smaller and smaller portions of string that goes around a circle, and like, how big would that string be? Okay. Then it goes, because, oh, interesting. I didn't see what Remy, oh, interesting. That's a good, actually. Oh, yeah. I actually, you're right, Remy. And I totally do have that. I just don't know if I could, a wall zoom. That's a good point. Okay. I don't know if it's going to get, yeah. You're right. All right. I'll try, but it might start getting very, I might start getting very, multitasky, but you're right. Okay. Yeah. All right. Actually, you're right. I'll try that. I know there's an easier way than, because I actually have special. All right. If I can't do this fast, I'm going to stop it. But he's right. And
It's the top one with the pen and the paper edit.
oh, right. But won't that? Okay. Oh, I see what you're saying. Okay. But then it's going to be permanent. All right. Well, all right. Yeah, I'll try. Okay. Yeah, this gets all, but okay. So I'm just going to do this one for right now, just to make sure we're on the same. And if it, so this one is, I don't even remember now what we said, 25.
5 pi.
Okay, cool. Okay, thank you. I guess that's not bad. Yeah. All right. Thank you. Yes. Okay. Okay. I'm not going to do the others now because you can see it sort of takes me a while. But yeah, now for all the rest of them, like, so then the next 1/6 of the string, okay, that would just be 10. I'm sorry, that would just be 20 pi feet divided by 6, which is like 10 divided by 3 pi feet. You could say, if you want, so you could say, okay, you could express it, since it doesn't tell you how to express it, you could say something like this. Right, something like this for the next one, if you guys agree, and etc. And it goes like that. I'm not going to write out all the answers, but you get the pattern, right? Now, we're trying to, you could tell whenever tests do this, or whenever my test, when it gets like really repetitive like this, really, it's trying to show you something. You can assume with things like this. We're not trying to trick you. When we ask the same question sort of over and over and over again, and maybe on your actual exam, we won't ask it this many times, and maybe we'll change the number slightly. I'll talk to you about that. But if things seem straightforward, don't look for a trick and assume there's got to be a trick. If things seem straightforward and repetitive, what it means is we're trying to build to something. We're trying to get you to put down the straightforward pieces so that somewhere eventually we together can put the straightforward pieces together and see a conclusion. Like, in fact, and I mean that honestly, like a lot of times with these kind of questions, my past experience, students, especially if they're used to science or they're used to physics, they keep thinking there's got to be a trick here. Like, what's he doing? This is too stupid. Like, why is he asking us the same stupid question? And then they make it harder on themselves. When in doubt, don't do that. when in doubt, don't assume I'm trying to trick you. Like really, assume I'm not trying to trick you, but do assume that if you think that questions are somewhat straightforward, that we're trying to put down pieces and we're trying to see something. And often, like you had this experience in this test, often in physics tests, I find more and more students telling me, it helps to realize when you're taking a physics test that we're not necessarily just trying to test whether you knew what you were supposed to know 3 weeks ago. We're not trying to find out if you knew what you were supposed to know in the past. Actually, we're trying to make sure that you know it. Like in what I'm saying is, with a lot of other kind of courses, you have to study before the test, and then you take the test and you hope to prove that you studied correctly and that you understood everything before you take it. Here, a lot of times when you take physics tests, that's the moment when things start coming together and you understand them for the first time. Physics tests are often designed to help you see everything at once, because they know that sort of like no one's going to do that until it's test time in a way. So if you find yourself realizing things in the middle of this test, like today or 2 days ago, or even in the real thing, don't stop and think, oh no, like I'm like totally behind. Like I was supposed to know this a week ago, or uh-oh, I better fake it and somehow give them the idea that I already knew this. No. We get that for a lot of you, you'll be finally understanding this material for the first time as you go through this test. So it's designed to help you get there. So don't ever think it's something, so it's not a trick, but it may be tricky, but it's not a trick. Okay, so it's going through this pattern. Like, what if you have this portion of the length? What if you have this portion? And you just keep doing the fractions like it's doing, right? Then it does the whole same pattern again, right? Just when you think you're out of the woods here, then it does the whole same stupid thing, seemingly stupid thing again, but now it does it for a radius of 2 feet. Okay, so this is I'm going to do a couple of the answers. In fact, I'll put back Jake's original answer at the top so we can compare. Jake's original, I guess this is good, Remy. I guess this is better than I thought this was going to be much more. Okay, so Jake's original answer at the top was 20 pi feet. That was for the whole, in fact, I'm even going to make it clear. That was the whole circumference was 20 pi feet. And notice, it's a circumference, it's a length that it's asking you, the length around the whole string, right? So you get an answer in feet, but also notice that your answer has this number pi in it. Like maybe in some ways it might have been, for some of us, it might be easier to visualize in your mind. Whenever you see pi, I encourage you in your mind, when you see pi, just think 3. Just when write down whole circumference equals 20 pi feet, but in your mind, you could think of that as that's 60. Just think of that. Okay, 60 feet. Like just so you can picture, we're talking about a real thing here, like essentially a little bit more than 60 feet. Okay, now you go down to the next section where it says you find that r equals 2 feet. Okay, and it's asking you the same freaking math again. It's asking you what's the length of the entire string. Again, we got 2 options here to cut to the chase. You can literally use the same equation that Jake used before. You could say C equals 2 pi r again, only now you'll plug in 2 for r instead of 10, right? And you'll get 4 pi feet, I believe, right? Or if you're following what's going on here, another thing you could do, so I'm just going to write, so whole circumference. It seems to me that the whole circumference here equals 4 pi feet, because another way to see that you might, sorry, did I say 4? Yeah, another way to see that you might notice is we just divided the radius by 5, like we had a radius of 10, we just divided it by 5. So it works if you just take Jake's answer, which was 20, and divide it by 5, and you get 4 pi feet, right? It's not a coincidence that that trick works, because circumference is directly proportional to radius. Okay, so am I making sense? Right. Okay, so we went down to an answer of 4 pi feet. Okay, and stop me again if I'm not making sense. Again, I'm not going to write out. And if I go like one more step just to see, it's the same pattern as before. If I go to half of the circumference, actually, this was a really good suggestion, Remy. Thank you. I thought it was going to be much more intimidating than it was. Maybe the way you feel about physics, I don't know, but thank you. Okay. So if I go one more step to a half circumference, I get 2 pi feet. Okay. And then I think you could do the rest of the answers and you could check them with me later or whatever, but you just keep doing the same pattern as you go down. But now, why are we going through all this tedium? Because, okay, now, like right away, just notice all the, well, I'll go one. Yeah, I'll go one more. Like each time you take a smaller and smaller section of the circle, you get a smaller and smaller arc length, of course. If you take half the circle, you get half the arc length, et cetera, et cetera. But it's also trying to show you that these proportionalities go down if the radius of the circle goes down. So now what it's saying is, now it's going, okay, wait, we're seeing the patterns here. We're seeing the patterns. They might not be interesting, but we see them. So now it says, let's cut to the chase. Let's forget this detail of the radius. Let's just go down to a radius of 1, where basically, let's just go to a unit radius and see what this pattern looks like when the numbers are not getting multiplied out by a radius factor. So if you go down to a radius of 1, right, the length of the entire circumference, it seems to me, the whole circumference, if you go down to a radius of 1, the whole circumference would be 2 pi feet, right? Now that is, I'm going to make a note. The length of the whole circumference around a circle of radius 1 would be a number of feet called 2 pi, basically a little bit more than 6 feet, right? If you do, I'll do one more just to show the pattern. If you go to half of that, if you go to half of a circumference, it's going to be pi feet. This is also a length. And it asks like 50 more stupid exercises. Again, now I'm going to say right now, in order to try to make this like an instructional experience, for the moment, skip question 4. We'll go back. Question 4 is maybe obnoxious. I'm not saying you won't have it. We can go back to question 4 when we're done with this. Like skip question 4 for the moment so that I can like make a point here. Oh, wait, do we ever? Hold on. Where is the point I want to make? I will get back to that, I promise, but where did it go? Wait. Hold on, I'm getting to. Oh, yeah, okay. If you skip all that stuff about pi strings and go down to this, to question D, okay? In fact, at least one of you actually texted me about this, like that day that you were doing it. And that's cool. Then at least 2 of you to ask me about this in the office. So I know that, so this is an important question. The one that's in your screen right now, number D, letter D. What it's getting at is it just put you through all this nonsense over and over. Because what we're trying to show you is that all of those, we're trying to show you that arc length is a perfectly arc length is an easy way to visualize the portion of a circle that you're looking at. God, I can't speak today. Hold on. Let me just get my thoughts together. Here, what I'm trying to say is this. If you go up to these answers at the end, if you go up to the answers for part 3, right? The arc length of string that you took all around an entire circle, as long as the radius was 1, was 2 pi feet. The arc length that you went around half of a circle, as long as the radius was 1, was pi feet. If you go a quarter of a circle, it's going to be, if you go a quarter of a circle, it's going to be pi over 2 feet. I'll write that. Though what those are are what we ultimately call radians. What those are, those are angles. Like what an angle is just a fraction of a circle. And the biggest angle possible is the whole circle. The next biggest angle, in a way, is like half of a circle. The most recognizable angle in the world is a quarter of a circle, right? This angle right here, what we call the right angle, what it is a quarter of a circle. And the easiest way, and therefore it's a quarter of the crust of a pizza pie. It's a quarter of the arc length of a circle. The easiest way to think of an angle is how much arc length would you get for every 1 unit of radius that circle has. So what we're trying to get you to see in the end is that angle measurement is just the number of feet around the edge of a circle divided by the size of the circle itself. It's just a way of asking how much crust would you get if you assumed your pizza had exactly 1 unit of radius. So what we're trying to say is that these answers that you finally get when you get to radius 1 feet, like we're trying to say, look, if the circle had a radius of 2 feet, when you go around the whole circumference, you get if the radius had if the circle had a radius of 10 feet and you went around the whole thing, you get a string of 20 pi. But that's because the circle's so freaking big. If you scale the circle down to a radius of 1, you'd get exactly 2 pi. If you scaled it up to a radius of 2, you get 4 pi. You're getting for every full circle, you're getting 2 pi crust for every unit of radius you have. So angle is just arc length divided by radius. In other words, I'm saying that the answer to this question right here, the answer to question, I keep losing F. The answer to this question, D. I'm saying the final numerical answers you found for 4A1, B1, C1, the final numerical answers you got for whatever answers you got for when the radius was 1, that's what an angle is. Those can be understood as measurements of angle. And number 2 question, using units of radians. What a radian is just how much string circumference you're getting for every unit of string radius. So all the things you were thinking you're measuring radius, sorry, I'll go on in a second, but we're asking to picture lengths of strings and how they get smaller and smaller as you take smaller and smaller portions of the whole circle. We're saying in the end of the day, and we're really trying to explain is why do you always have to deal with pi? Why is pi in your life? Why do you care about pi? Because it happens that a string that goes all the way around a circle is always 2 pi greater than a string that goes straight in toward the center. That's where the pi is coming from. The pi is coming from the fact that the circumference of a circle is 2 pi times the radius. So we're just stuck dealing with that pi in all of our answers. But the pi is just a number that's coming from that. So I'm saying the answer to D1 could be understood as measurements of angle, and where it says use, I'll type it in. I keep forgetting I can do that. I'm going to type it in right now. I'm saying the answer to this is angle and this part I'm saying using units of radians. Okay, I'm even going to also, as long as with Remy's permission, I'm also going to I'm also putting, as long as we're, oh, good, I'm so stupid. As long as we're doing it this way. if you're following along like this, if this is helping, then I'm putting the answers in, which I hope it is. I'm putting quotes around that units. I'm going to go back to that. I'm putting quotes and asking you to put quotes because radian is and yet is not a unit. It's not actually a proper unit. And some of you have raised very good questions about that I want to address. So put quotes around that word unit. I'm also going to say now, because I could see I'm getting myself all in a dither, the part that I skipped, you find that r equals pi feet. All we're trying to show there is that pi is a number, a radius could be of any number. You would do the same thing here, that if you follow the pattern, you would just follow the same pattern with, but I'll tell you right now, I think this whole thing got tedious enough for many of you, and it's just confusing enough for some of you that right now you can cross out this 4. Don't worry about the 4. It was an overreach. You won't be on your test is what I'm saying. So I will do like this. Okay, I hope that's clear. All right, just cross that out is what I'm saying. Okay, don't worry about 4. Let me look at. Oh, there's something in the chat. Thank God. Okay. Oh yeah. Oh, that's. Oh wait. Sorry. Is that? Wait, that's so funny. If I just saw Remy's thing. If I'm sort of praying, if Remy means that part that I just said X, then totally yes. If you mean the whole rest of it, I mean, yeah, and good call, Remy. If you mean that number 4, yeah, I'm crossing it out right now. I hope that's clear. If you mean all the rest of that, what we just did, I'll tell you right now on your actual exam, all the rest, like 1, 2, and 3, it will definitely be shorter on your exam. It goes on way too long here. It's way too tedious. It sort of ends up defeating itself because it's so long, but a much shorter version of the 1, 2, and 3, a shorter version, like basically a little bit of 2. We'll do a little bit of a radius that isn't 1, and then a little bit of the radius of 1, because we just want you to see that that's the whole point. To measure angle, I'll just say it one more time. To picture angle is really just to picture arc length, but per radius of 1. Because if the radius is any bigger than 1, then automatically the arc length gets bigger, and that throws off the perception of what we're looking at. So we're just trying to get you to see that to measure an angle, talk about an angle, is to look at a fraction of a circle. But yes, I don't know if that answers Remy's question there, but yeah, 4 I'm omitting. 4 is omitted. And 1, 2, and 3 will be a lot shorter and condensed. Oh, wait, let me look at the chat. Oh, part D. Well, part D. Well, I see what you're saying. I mean, I'll tell you this, I clearly should word it differently in your exam. And that's part of why we're going through this right now, is to find out things like that. I agree that the wording somehow didn't work for people this time. Where did it go? So I will try to do it sort of differently, but I can't make it won't look like question D. Yeah, question D itself, I'll write for myself and for you guys. I'll write this. Okay, I can't promise how I will, but I will tell you the concept that I really want you to know, the concept that all this is trying to get at. And I know I need to go on. And that one day that we had the most tedious, I just want everybody to see. Here, I'll write it as big as I can on this. Or please everybody write this down, whether I can write it in the chat or. What I'm trying to say to everybody Um, okay, I don't know. I mean, this is, I don't know if this, that thing that I just wrote at the bottom of the page, and the mathematical way to write it is theta equals S over R. That's the thing and really that should be a triple equal sign. That should be a triple equal sign. But what I want you to know that we're somehow trying to get you to see and test you on in this test. We want you to really see that just that theta measured in radians equals arc length measured in meters divided by radius measured in meters. That's the key takeaway of this whole thing. And in English, the key takeaway of this whole thing is that an angle is a portion, an angle is a dimensionless fraction of a circle, which for physics means an angle is a dimensionless fraction of a cycle. And maybe please write that down. Like, I know I'm getting all tedious with the takeaway of this whole section. The thing that somehow will ask you a question, make sure that you understand, is that an angle is a dimensionless fraction of a cycle. And when I say dimensionless, what do I mean? I mean that technically it is meters of this per or divided by meters of that. So the meters technically cancel out. So when we say something like pi over 2 radians, what I want, and again, please be taking notes on this in your way on the exam right now. Like, this is what we're trying to ask you. We want you to understand that when someone says pi over 2 radians, what they really literally mean is a quarter of a circle, or in physics, a quarter of a cycle. Okay, pi over 2 radians means 1/4 of a cycle. And note when you say that, cycle is a word. I mean, it's a word of English that's definitely telling us what we're talking about. Oh, right. Pi over 2 radians is equal to a quarter cycle. It's not just a quarter anything, right? It's not a quarter of a shoe. It's not a quarter of a dollar. And I'm not being sarcastic. I'm trying to make this clear. Like, pi over 2 radians is equal to a 1/4 of a cycle, which is a very specific thing, a cycle, right? But, and so is a radian. A radian is a very specific thing. But notice this. What is a radian? What is a radian? It's a meter of arc length per or divided by a meter of radius. So, i.e., it's a portion of a circle. But it's specifically a portion, a fraction. Like, notice the meters cancel out. So at the end of the day, this is why I put quotes around the word radians. At the end of the day, a radian is definitely a thing. I mean, it's real. Like, we care about it. It's not the same thing as a shoe or whatever, but it's not technically actually a scientific unit of MKS, for example. It's not actually a unit like a meter or kilogram or second, because it doesn't actually have a specific size in space. Like, and you'll see as we go on furthermore here, just like a cycle is a thing. Like, a cycle is a thing. It's important that when I say pi over 2 radians is equal to a quarter of a cycle, I'm saying something meaningful, a quarter of a cycle. But a cycle is not a unit. A cycle is not a unit. You can't like cancel it out with other units and multiply. You can't say like 4 cycles times 3 feet equals 1 Newton or something like that. A cycle is not a unit. Why do I say that? Because a cycle can come in any kind of size in the world. A kilogram is always literally that big, a kilogram, or that heavy, right? And a second is literally that long in time. But a cycle could be any size. So it's not a unit. So a radian is not. That's why radians are tricky. That's why we're going through all this, because like I'm yelling, not because I'm I'm unhappy with anybody. I think radians are like hard. I think it's like a weird concept. It's like a super important concept, but it's weird. It's like a unit, but it's not a unit. Okay. So at the end of the day, this whole thing that, yes, I'm listening to Remy, I'm listening to everybody, I'll listen to anybody who talks during this class who can get a word in edgewise. I will shorten and make all that less annoying to you. And I will take out question 4 and I'll rethink question D. But the thing that you want to study and the thing that you want to know is, do you really get that from now on, when we say pi radians, what we mean is a half cycle. When we say 2 pi radians, we mean a full cycle. When we say pi over 2 radians, we mean a quarter cycle. We were just trying to put you through all that crap, like putting you through musical scales. So at the end of the day, like you can recognize like some music, right? Okay. We want you to be fluent. In fact, I'm going to say this right now. I'm going to go, I promise I'm going to go on, but let's just see if we've accomplished anything. Like, we'll just have a little race here just for fun. Okay. And also to calm me down, because I know I'm being a freak. What else is new? But like right now, I'm just going to, how about this? Okay, yeah. Okay, well, yeah, just in the chat as quickly as you can, just as a race, just for fun. In the chat, please put that in terms of portions of a cycle. Like phrase your answer as a portion of a cycle. Like, so you like either say whole cycle or half cycle or something like that. Okay. What is pi radians? Put it in the chat. I'm not gonna, and you can put it in private. I'm not gonna embarrass anybody or anything. It's not a test, but just for fun to make sure I know what I'm doing. Ooh, that's fat. I'm gonna say it again. By the way, I'm not even looking yet. I see in the chat. I'm not even looking at answers. I'm gonna say again, pi radians. How much of a cycle is that? Put it in the chat, please. Pi radians. I see 2 people in the chat. I don't even see what they're writing yet. I just see that there's 3 people in the chat. That's awesome. I'm going to wait a little bit more. I'm going to say it again. This is practice for you guys, okay? And the more you can satisfy me that you actually get this, the less tedious this whole part of the test has to be. Like, what is pi radians? Like, how much of a cycle is it? 2 cycles, 3 cycles, a half a cycle, a quarter of a cycle? What is pi radians? There's 3 people in the chat, but I've not looked at their answer yet. I just know that there's 3 people in the chat. There's 5 people in the chat. Awesome. I'm going to wait a little bit more. Like, can we go for 7? Can there be? And you can even put in the chat, I don't know. Or you could put in the chat, I hate you. Well, maybe don't put that. But like, you could put in the chat, you lost me 20 minutes ago. Or you could put in the chat, I'm really bored. Whatever. But maybe not that. But there's 7 people in the chat. Okay, I'm going to look at the chat. Awesome. Awesome. Okay. Awesome. In the chat, I see 1, 2, 3, 4, 5, 6, 7 answers, and they're all the same, and they're all correct, and they're all a half a cycle. Okay, so if you get that, okay, so we're right, we're together. Okay, so I'm going to go on. Now, I will say right now, I will tell you, there's 2 questions that now come that are very similar to each other. You don't have to have both in your exam. I don't know, this exam got unwieldy over time. That's why we're doing this. There's 2 questions that are very similar. Let's just go to one of them and I'll cross out the other. Let me just find it. Where to go? Yeah. Okay. Well, and I'll give you, okay. What we're going to do right now, we're going to go over this question right here. 5, where it says a pizza is cut into slices for one of the slices, blah, blah, blah. Okay. The thing that's right in your screen right now. We're going to go over that. I'm going to like just teach it to you right now. I think that this one's like a hard question. This one really puts things together. I think it's hard to see on your own, maybe, but once you see it, you'll see it. I'm going to tell you it, but I'm also going to tell you right now. Here's the deal. Like, this is also why this is a practice exam. I'll tell you right now that question H is exactly like the thing I'm about to answer. 5, there should have been a letter after it, but this 5, you won't have both on your exam. But the fact that both appear on this practice exam indicates this is one of those times where I'm going to tell you the answer to this, and then it's going to be a slight variation on your exam. Like, don't just memorize the answer, get the concept and be prepared. So you have 2 different possibilities to practice. If you get both of the questions on this, then you'll know you get it and you'll be prepared for your exam. So what it says here, I'm looking in the middle of the screen, and it says 5. A pizza is cut into slices. For one of the slices, the length of the edge precisely equals the arc length of the crust. 1 string would fit. Okay. Now this is hard for me to draw. So in radians, precisely how large is the angle between 2 edges of the slice? Now, I want to answer this. I'm going to answer this. I'm not going to torture you, but it is an important one. I think it helps a lot. I know a couple of people have worked on this with me already, so I know about them. But other than those people that have already asked me questions about it, I want to know before I explain the answer to this. I'm talking about question 5 in the middle of the screen. Before I explain the answer, can I get a show of hands if you feel like you understand the question? Like, honestly, do you get what number 5 is asking? Like, say yes, or say actively yes or no in the private chat, please. Like, either right, yes, I understand the question, or no, I don't. Thanks. Okay, I'm looking. Oh, cool. Okay. That's 2 people. I'm gonna wait till there's a few. Cool. Thank you, and I really appreciate this participation. Okay, great. I see like 4 people in the direct chat. Great. All right, so I'm going to assume that those 4 people are speaking for the group, so you understand. Okay. Now I'm going to tell you, if you look, it's all about that purple thing that I wrote there at the bottom, where it says angle equals arc length per radius. If you write that mathematically, you might write theta is triple equal sign S divided by R, where S stands for arc length measured in meters and R stands for radius measured in meters. Okay, that's what an angle is. So they're asking you now to picture a piece of pizza. They're asking you now to picture a slice from a circle where, like, the edge is exactly the same in length as the crust, right? So what they're really asking you is to picture like a really squat piece of pizza, like not a long, thin piece of pizza, but a squat one, like a one that's so squat that it's like a rounded version of an equilateral triangle. That's what they're asking you to picture, where the curvy side is just exactly as long as one of the edges. And of course, the other edge both of the edges would be as long as each other. So they're basically asking you to picture a little equilateral triangle slice of pizza. Now, I don't care whether the pizza is really, really big or the pizza is really small. What you're picturing is the same portion of the whole pizza, and it's a certain angle. And again, that's what we're trying to get at here, that it doesn't matter what size the circle is, an angle is an angle. The question is, what would this angle be measured in radians? And the answer is this. If you write down on your piece of paper, theta equals S over R, right? That's the definition of theta. That's always true. That's a triple equal sign. This purple thing really should be a triple equal sign, by the way, and it really bothers me that it's not. Hang on one second. Yes. Okay. Yes. Okay. Yes. Now, okay. Now aren't we all impressed that I could do that? I am. So that's a triple equal sign. That's the definition of angle. So theta, triple equal sign S over R. But now in this particular question, it's specifying that the arc length and the radius are the same. It's specifying that S equals R. So that means in this particular question, I could write down that theta equals S over S, or I could write theta equals R over R, right? Because in this particular question, the whole condition that it's asserting is that S and R equal each other. So I could substitute in one for the other, not always for all angles, but for this angle that it's asking about. So I would write down theta equals S over S, or theta equals R over R. But what is anything divided by itself? What is 8 divided by 8? Anybody in the chat or shout out? What's 8 divided by 8? Looking in the chat. Awesome. Yes. Awesome. I'm seeing the chat. Yes. Thank you, both direct chat people. But they both wrote as 1, right? So what does that mean? That's your answer. What we're saying is the angle that is formed when arc length equals radius is exactly 1 radian. And I really do want you to get that. And I'm telling you right now, whatever, this question is definitely on your exam, some form of it. It might be this exact question, or it might be the one down below. I'll show you that in a second. But what I really want you to see, after you go through all this nonsense, after you go all this, that angles measured in radians are just portions of circles, pure fractions of circles, that's one thing to say that in English, but it's another to say, if you back up and say, okay, so fine, so that's what, but then what is a freaking radian? Just like, what is it, Yaverman? I'm like, what is a radian? I would say a radian is that angle that you see when, if you ever cut a piece of pie that looks like a rounded equilateral triangle, that wideness, that angle is a radian. To be more specific, if you really think about it, in order to make that, if you think about pizza and you try to cut not into long, if you cut into long, thin slices, you get a million of them. You get like 25, not 25, like 24 long, thin slices if they're long, thin. But if you tried to cut a pizza into triangles that were basically equilateral, like what we're saying here, you would find that you would cut the pizza into basically 6 of them. If you think about it, you wouldn't be able to cut it into 12 or 24 or 4. Like 4, they'd be right angles. No way. That's not like that wouldn't be an equilateral triangle. But if you wanted like an equilateral triangle, you would cut the pizza into about 6. Coincidence? No, not a coincidence, because there's about a little bit more than 6 radians per full circle. A full circle is 2 pi radians. 2 pi is a number a little bit more than 6. It's like 6.28. A radian is a 1/6 of a circle. It's that angle that it's a little bit less than 60 degrees. Equilateral triangles have 60-degree angles, right? So I'm saying at the end of the day, if you want to picture what a radian is, picture that. Picture like the angle. Picture basically a little bit less than a 60-degree angle. Now, of any circle you want, of any size, so that's why it's not a proper unit, because it could be of any circle. But a 60-degree angle, is a little bit less, is what a radian is. That's what it's trying to say there. And if you just skip ahead for a second, if you skip to question H, it may seem like a really hard question when you look at it for the first time. But notice this question is just literally, it's the same question. It's only saying now if the length of the crust is precisely equal to twice the radius of the pizza. Actually, I'm going to ask you to do this right now. It's asking you, yeah, it's asking you, how many radians would this slice be? If you had a slice where the crust length was twice as much, in other words, if S were, if S were 2 times as big as R, how many radians would this angle now be? And I'm going to ask you to put in the direct chat. It's not a trick question. If you follow what I just did in the question above, then you can do this one. It's an answer very similar to that. I'm also going to tell you right now, one of these kind of questions will be on your exam. Maybe your exam will say like, what if the crust is 3 times as big as the radius? Or maybe I'll be like, woo, really tricky and say like, what if the radius is 3 times as big as the arc length? But if you get how to do this, you'll get how to do this. So I'm going to put, I see one person in the chat. I'm not going to even look at the answers for a minute. I see one person in the chat. Bless you. Thank you. Quark, bless you. I'm going to wait till there's like 4 people in the chat and then I'll look, but try to get, and again, you're not going to have both questions on your exam, but you'll have like one of them on your exam. So I'm looking at H. I'd like you to try to do H based on what I just did. And I'll tell you again, the answer to the one above, the answer to this thing, to 5, badly written, badly labeled, the answer to that one is 1 radian. The answer to 5, sitting here on the screen right now, I should write it somewhere. I will write it right now. The answer to that okay. So that's the answer to that. Oh, there's 4 things in the chat. That's awesome. So I'm looking at the chat now. Okay, interesting. Okay. All right. So now, all right. So there's different answers in the chat, which is good. I'll get to that in a second, but there's also a fair, honest question in the chat. Someone in the direct chat is asking, why did I write 1 for this answer? So the reason I wrote, I'll try to do the work up here if I can. Here, let me see if I can do the work. The reason I wrote it. The reason I wrote 1, and I'm glad someone has the honesty to answer, I really do. The reason I wrote 1 okay. Actually, the reason I wrote 1, I can do it down here. If you notice down here, where it says in purple, the angle equals arc length per radius. Okay. So they're asking here in this question, what is the angle that you get when the arc length and the radius are the same? So they're asking they're asking if they're specifying that the radius and the arc length are the same, that's what they're saying here in the question. What kind of size slice do you get? What kind of portion of the circle do you get? If the edge length, the crust, the crust length, the arc length is the same as the edge length, what they're asking is, what if arc length is the same as radius? So we could substitute one for the other. It's like saying, what do you get when what angle do you get when it's arc length divided by arc length in this question? Like the definition always of angle is arc length divided by radius. But the application to this question, the double equal sign, is arc length divided by arc length, if they're actually both equal, like the question says. So anything divided by itself is 1. So that's why I say the answer is 1. So I'm trying to, I don't know, does that help person who asked in the direct chat? Wait. So maybe the person in the direct, hold on one second. Okay, wait. So now I'm looking at, now a lot of things are happening in the chat. So hang on one second. Hold on. Okay, I'm going to respond for a second to people in the direct chat. Give me a moment. Okay, wait. Yes, that's good. That's good. Yes. Okay, people are rocking in the chat now. I think everybody is catching themselves up. Awesome. Hold on. I'm just catching. Okay, wait. Right. Okay. And wait, there's something else in the chat. Okay. Wait, there's just one other thing in the chat. I'll be back. Wait, I could have sworn I just saw. I thought someone asked me something and I didn't. I could have sworn. Okay. Oh, there. Oh. Okay, I think I responded to everything in chat, although I could have sworn I saw something in the chat asking me to do something, and then it's gone, but okay. But okay. I think so what I think I've just seen in the chat is that I think you're clear on number 5. H, the answer would be 2. Yes, the answer would be 2 radians for H. Like if the arc length is twice as big for the same amount of radius, that's twice as much angle. Like, I mean, I know we're kind of, I know I'm beating a dead horse here, kind of. But yes, the answer to H is 2. And if, you know, and if I asked you, well, what if the radius was 3 times as much as the arc length, then the answer would be 1/3 and so on. So I'll ask you, I just want you to know in the end, that's what a radian is. A radian is a little bit shy of 60 degrees. It's that chunk. It's that chunk of a side. It's a radian. The other way to put it is a radian is approximately a 1/6 of a cycle. That's what a radian is. Okay. The answer to F and G, I'm just going to say, or the answer to F, oh, here, I'll just write it. The answer to F, and then we'll go on. Right. Tell me if so I think the answer, right, the answer to F is pi over 4 radians. I'm just basically, as long as you know that 2 pi is the whole cycle, then any portion, anybody, so 1/8 of it's really trying to say what's an. So maybe on your exam, for example, I'll tell you right now, hint for pro tip for people who are paying attention right now. Say I asked you that question F on your exam. Probably, if I'm smart, then question G instead would be something probably, all right. Probably question G, I would be smart if I just wrote in radians express a 1/12 of a cycle, right? I just like, because that's what we're ultimately trying to get at with all this, right? And the answer would be.
I got it. For you.
Right. If I said literally what is a 1/12 of a cycle, it's the same thing as cutting a pizza into 12 equal size slices. The answer would be pi over 24 radians. Okay, so we already did H. We said that was 2. I hope we're clear on that. Okay, so that covers that. Okay. Oops, sorry. I actually love that feature. That's not what I meant to do. Okay, so let's go on now. All right, now this one I know we talk about beating a dead horse.
Sorry, but
I'm sorry. Yeah.
when you do H like mathematically, I still don't understand how you do H.
Oh, that's fair. Yeah, that's fair. Yeah, I kind of did blow by that. Yes, very fair. I'll show you. Yes. Like this. Well, here, I'll do it literally mathematically. Yeah, it's just hard to write. Actually, I think, yes, I will. Hold on, give me 1 second. Yes. Should have done this before.
Good job, guys.
Good job, Mom.
Okay, I'm gonna drive the boys.
Yes,
Felix
good.
is with me.
Yes, thank you. Good luck.
Yeah.
Yes, yeah. My whole class is enjoying them very much right now. Yes, okay, wait. Oh, it's not working. It's hoping, no, it's not working. Okay, I was trying to do it mathematically, but okay. I mean, I was trying to do it with symbols, but okay, whatever. Okay, so you do that, theta equals S over R, but here, yeah, and I'll tell you, if you're doing this on your exam, honestly, what you really want that to be a triple equal sign. I don't know why. Oh, that does work. So why doesn't the theta work? Hold on 1 second. I'm going to try to do this right if I can. It won't let me do the theta, but all right. So the definition of theta is arc length over radius. That's a triple equal sign. That's like GDP step 3. But then here, if we're now step 4, particular application work, here in this problem, it's saying that S equals 2 times R. Like that's what the English is saying, is that the arc here we're specifying that the arc length is 2 times the radius. Again, notice first I have a triple equal sign. I'm saying in general, theta equals arc length divided by radius. But now that's true even if you're not like looking at this exam. But now in this exam question, it's specifying that S equals 2R. So therefore, like here, I could say that theta equals 2R over R, right? Like I'm just and I'm not trying to be weird. Like I'm glad you asked. Like it definitely is worth seeing. But I'm saying specifically based on the information they gave me, if S is equal to 2 times the radius, then I could substitute 2 times the radius for that letter S. So I now have that theta equals 2R over R. But then, and this part's like a little hard to, but then the R's cancel out in math, right? So I just get that theta equal, I don't know how to put that part. I can't really do the cross out right here, but do you see what I'm saying? Like, and I'm honestly asking her, maybe it's in the chat. I think it's good that you just asked, but tell me if it, so that's my answer, is that theta equals 2 because theta equals 2R over R and the R's cross out. Does that make sense? Or tell me if that makes sense. Oh, and someone's, oh, cool. And somebody totally, oh, and it does. Okay, great. Thank you. And I do see, I'm not going to say your name, but well, someone in the direct chat just totally did what I just did, which is great. But it was great to ask for that because you're right. I do just like talk these things in outer space and it doesn't do anything unless you see it. But Remy, does that make? Oh, question 5. So someone else, wait, so our things in the chat. The unit circle for question 5. No, someone's asking in the chat, like, wait, so we weren't supposed to use the unit circle? Anytime you can use the unit circle, I'm pumped. I mean, if you use the unit circle and you got the right answer, no, please do. Sometimes I'm trying to avoid it because I know some of you hate it, but also it's hard for me to do like on this board right now while I'm writing on the test. But no, it really is all about the unit circle. So if you can use the unit circle and you know what you're doing, then great. So wait, so my answering is this. Thank you. Okay, so it's G 2 pi over 3. Let me look at what's G 2 pi. Oh, did I get that wrong? Wait, 2 pi over 3. Why is it 2 pi over 3? Well, I think G. Oh, wait, okay, one sec. Oh, did I make a mistake? Wait, 12. 2 pi over 12. Oh, did I make a mistake? Pi over 6, it should be. Sorry, I said pi over 24. I think I mean pi over 6. You're right. Sorry, someone, I think, hold on. I think we're both. I mean this one here. I'm sorry. Someone just caught something in the chat. I think, I'm not sure if this is what they were saying, but right. 2 pi divided by 12 is not pi over 24. It's pi over 6. I apologize. Is that what you? I'm going to pause for a second. Are we all together? So thank you, person in the direct chat who I may have inadvertently just pointed that out. But are we all together? Cool. Can I go? I'm going to go on. Or can I just thumbs up? Oh, chat. Just something in the chat. Okay, and all good. Okay. Okay, no problem. No. We're all good. Okay, so I'm gonna go on and let me look at 6 o'clock. Okay, let me just. Oh yeah, this business. right now, this thing is all supposed to be about the unit circle. But I know things are getting a little tedious at this point. I'm tempted to say, hold on, I can't, I don't want to make any promises that I can't. I feel like this we beat. I think if I talk about this right now, everybody is going to like gouge their eyelids out. Like, I think everybody's going to hate everybody, particularly me. If so, I'm not saying this is not going to be on your test, but right now, this 8, whatever's on the screen right now, I'm going to skip for right now. I mean, this is supposed to be about the unit circle, this part. What, I mean, and of course, you could just get these answers on a calculator. I know that. And sometimes we have rules about calculators, but like usually we don't. So in some sense, it's kind of a fool's errand. Like the point of this is supposed to be that you're using the unit circle. And what I want you to know is that if you draw the unit circle, cosine is the coordinate, is the x coordinate of a point on the unit circle, and sine is the y coordinate of the point. I don't think I want to talk through that right now because I think we have many times, and I think you either get it or, I mean, or even if you don't get it, I think right now you'll kill me if I keep talking about it. The one thing I could say is I could just bang through and tell you the answers to these right now, no problem. And if you want me to do that, I will do that. It's just that, of course, you could check them on your calculator. So I'm not really sure even what good it does you. Okay, I'll move on. All right, thank you. Someone in the chat just said, I'm going to move on for now. If we can get back to that, we will. But I'm going to move on. And excuse me, sorry. That is not personal, I assure you. I will say this, though. I know what this question is meant to get at. I do know what this question is meant to get at. But it's from the old days before COVID when we were all together and we were really going crazy with these protractors and these compasses and straight edges. So you see where I'm going with this right now. This business right here. I will say. Okay, this business I'll cross out. It may not even look different to you. I don't even know if you can notice but the difference is that those angles are a little bit weirder. And we were asking you in the old days to actually show how you understood the weirder angles from drawing triangles and constructing stuff. It was all a big drawing thing, and it's not worth it now because we're not together in the same room, and it's ridiculous. I mean, so that's crossed out. Okay, I'm going to move on now. Okay, now we're getting to the physics, which is what this is really about. Now, this is about the physics. Now, this part, of course, it's familiar to you. I know you've seen this before, and it's probably getting boring and repetitive, but maybe, hopefully, it's getting clear. Let me just look. I'm just scrolling through to see what. Here's what we're going to do right now. I mean, I believe we've gone over this exact one in an online. Yeah, I'm really afraid of really boring you. I'm gonna ask you in the chat. Tell me in the chat. Tell me what you want me to do. Tell me, do you want me to go over this? Do you think you have this clear? Do you have a specific question about this? I'm just really afraid of of boring the crap out of everybody at this point. Move on. Okay. Oh, okay. Oh, okay. Okay. Wait. Okay. Okay. No, I'm seeing in the chat and I appreciate the honesty. And no, okay. I mean, I am okay. Okay. So I'm tempted to do something though. Okay, I will walk through this and I'll try. And again, you could tell me when to move on. Let me just see if I can make this clearer. Okay, you know what I want everybody to do right now? This question, of course, it's going to be on your exam. It's going to be changed just enough. It's going to be changed a little bit. On the one hand, hopefully to make it a little bit clearer, hopefully to make it more to the point, but also to make sure that you don't just memorize your answers and you actually do it. So I'll give you an example of what I mean. What I'm going to ask everybody to do right now, like whatever answers you got in the lab, fine. But right now, to get this closer to what it would look like for your exam, right now, let's start by doing this. Let's so I'm making it a new question so everybody can think for the first time right now. But honestly, I'm making it a little bit not easier, but more direct and more clear. So here's just so you know that I'm changing. Okay. Okay. And I'm going to warn you, what I want everybody to do is right now, try to do the question. I mean, we still have time also to get your blood moving. Right now, try to do the question as I just rewrote it. Okay. I wrote it to cycles per second. And then I just want you to measure in hertz and then measure in seconds. All of that is a little bit more straightforward. And then we'll talk about what it'll actually look like on your exam. But for the moment, everybody take a breather and redo this right now for, and I will walk through it. But just try it yourself right now. In fact, I'll also say this. So if you, I see there is things in the chat. Once you think you have answers to A, B, and C, I would ask you to put them in the chat, or once you give up, like just once you think, if you're still thinking, then please think. And we obviously all could benefit from some time to think. But once you either think you have answers or you just think you're done thinking, let me know in the chat. I'm going to wait till I have a bunch of responses. And I do mean the private chat. So again, just try to answer A, B, and C as they are written right now. Once you have answers to A, B, and C, or you give up, which is fine, or like whatever, your brain is just fried, which I could certainly relate, put in the chat, but I'm going to wait till I get like 5 things in it because especially because, yeah, I think this is best now. Some people said they need help with this. Some people said that they think their friends need help, which was very nice of them. Some people think they're set on this, but then I think this is a good moment of practice for them if I've just changed it. Like, let's see where we're at. So I'm going to wait till there's like 5 things in the chat. Also, I'm going to shut up. But again, if you've hit a wall, please tell me in the chat. There's no shame. But let's not hold up the class. Like, if you're done, if you're not going to do any more on it. I mean, or if you're just like spaced, whatever. If you're just done and you know you're not actually thinking about this problem, let me know in the chat so I'm not waiting for you. Okay, just like, but anybody who is thinking, I want to give them time to think. Oh, wait. Wait, I wasn't looking. Wait, so now I do see Remy's. Oh, wait. And by the way, if some of you are sending direct messages that I'm not getting, oh, I see what's happening. No, wait, be careful. Right, because I'm logged in 2 different ways. I may not be getting, right, I'm sorry, I'm not, Remy, I'm not, I thought I saw something and I couldn't find it. You know what's happening? They're going to my board. So I saw something flash on my board. I could have, there was something I knew from you and I couldn't find it again. They're going to my board. If, let me change the name on, you want to, but I'll look on the board. Wait. Where is the channel? Oh. Wait. Uh, okay, wait. Okay, so now a bunch of things are going. Oh, okay. So wait. Uh, Wait, okay, I'm gonna shift for a second. Oh, sorry. All right, so hold on. I see now that a bunch of messages went to the board. I don't know why. I don't know why this happens. I would still like people to work on this. Okay, I'm gonna switch screens for a second. So there was a whole string of messages that I missed. And I apologize. I literally did not see them. It's true. They were in my, but oh my God, I wonder how much else I'm missing. But one thing, I'm going to switch for a second and show you. Okay, just for a second, going back to this. So I forget which question this was, but if arc length is twice the size of radius, this is what I did. Then I'm saying, and the question was, find theta measured in radians. Right, that was the question. And I'm talking to everybody, but hopefully, Remy, you could see, because I see that a lot of the messages were going to the wrong place. So this is what I did. I'm saying, in general, by definition, theta in general equals S over R. But then I'm saying here, S equals 2 times R. So I'm saying here, therefore, theta equals 2R over R. But if that's the case, what I'm saying is just like before, if you ignore the 2 for a second, like anything over itself is 1. Like 7 divided by 7 is 1. So whenever you, and so, but pretend R is 7, it would be 2 times 7 over 7. That would be like 14 over 7. All that would remain is the 2. I'm basically saying whenever you have something divided by itself, that equals 1. So you can cross it out and just say that term R over R itself is 1. So the answer, so technically, I guess what I'm saying, if this helps to put in this step, I'm saying technically we're getting that the answer is theta equals 2 times 1, which is to say 2 radians. I don't know if that, now I'm hoping that my messages, it's hard to check the messages both in the book, but did that help? And maybe I guess I am specifically saying, Remy, does that help? Hopefully it did, because I can't, it's hard, especially when I use the board, it's hard to then see the messages on the board. I'm going to go back. Let me see. Oh, see, now you see, you can see that now that. Oh, what is S? Okay, sorry. See, I don't mean for you guys to see. What is S defined to be? S is arc length, is the size of it's the length of the piece of string that you would put along the curved part of the circle, or in the case of pizza, like along the crust. So the question was, what is the angle such that S is 2 times as big as R? What is the slice of pizza such that the crust is 2 times as big as the radius? And that's how I did. I don't know what. Oh, so I'm back to answering direct chat. I try my best. I promise. Like, I'm not trying to. I love the chat. I am missing it when it goes to the board, and I don't know how to control for that fact. Okay, thank you. That's awesome. Okay, thank you. Also, if I get time, of course, I can give you all. Well, I don't want to confuse people. I could give you all of you another practice on that to make sure you get it if you want in a minute. But let me go back to this other thing that we were doing now, if that's okay, because I'm starting to get things in the chat about the question I was asking. Hold on. Okay. Oh, and I'm running out of batteries too. Oh my God. Okay, hold on. We'll go back to. Okay, I'm going to switch back to where it was. I'm also going to plug in. Excuse me. But I'm going back to the other question. And now, because I just, double task there, I'm going to just assume that people have had enough time or as much time as they're going to use on this. Excuse me, hold on. I just need a plug. Oh my God, I need a plug and 7 Pokemon and 2 therapists. Hold on 1 second. Okay. Oh, and the board goes, and I need my board to disappear. That's what I also need. Yes. Okay. Okay. What I'm going to do now is go back to I'm going to go back to the problem that we were going over, which is this, right? Okay. Now I'm going to say the answers again to just get this back on track. I saw some things in the chat about this new rewritten 10 ABC. I saw some things in the chat. I believe what I saw was right. I might have missed some things in the chat because it seems to be going to 2 places. I apologize, but I would tell you, okay, if the rate of oscillation of this barn door is described by an angular frequency of omega equals 628, or in other words, roughly 200 pi radians, right? That's like the same number, just written 2 different ways. The first question is, how many full cycles per second are completed on average by this barn door? Well, the answer is, I believe that the answer is 100 cycles per second. I believe the answer to A this is so stupid. Sorry. Hold on. I'm sorry. I just realized that the fact that I'm writing all over this document is not as great an idea as I thought. 1 second. Hold on. Well, anyway, the answer, I'm about to write out why, but the answer is okay. The answer is 100 cycles per second. Now, where did I get that? Because there's 2 pi radians in every cycle. So what I'm literally saying, so the answer to this would be F, standard frequency, equals 100 cycles per second. If you want to know where I got that from, I'm a little loath to write this in the math right there, right now, but where did I get that from? If you want, I divided radians per second by 2 pi. If you want an equation for that, I'm saying omega equals 2 pi F, or F equals omega divided by 2 pi. Why? because omega measures in radians per second, F measures in cycles per second, and there's 2 pi radians in every cycle. Like a cycle just equals 2 pi radians. And honestly, and I don't mean this in a mean way at all, but far from it, but all the ridiculous number of questions that we just slog through for all the rest of the tests and all the, in a way, all that is just trying to like hammer that in, because for some reason it is a weird idea. Like, and I know that, and it takes a long time for it to sink in, but really the conclusion of all this unit circle stuff and all of this grinding through trigonometry is we're just trying to say that 2 pi radians is a fancy way of saying 1 cycle. But it's a lot easier to use pi and radians when we're doing the math of cosines and so forth. So we use them. But in the English or in the laboratory, when you're picturing what's going on, it's a lot easier to picture or talk about cycles. So we use them as well. So the conversion between the two languages is that 1 cycle is equal to 2 pi radians. So if omega equals 628 or 200 pi radians per second, that means that F, standard frequency, is 100 cycles per second. Let me just look at that. And I believe some of you did put that in the chat. Oh,
May I ask a quick question?
please, yes.
Okay. So, when I did this, I did the, hold on, my brain. The 628, this is for like the original question. It's the 628 over the 2 pi, but then you put for the like altered question, I did 628. Is 200 pi like a part of it? Because I did 628 times 200 pi over 2 pi and it canceled out. So maybe I read that wrong. I just wanted to like ask.
Well, that's really fair, because I was just, someone else in the direct chat literally said the same concern, and I was just about to type to them. Yes, okay. I'm trying to say.
Oh, got it. Okay. I thought I was going crazy for a second. Okay.
No, you're not going crazy. I'm going you crazy. I'm crazying you. Yeah. No, I'm right, and I apologize. There's someone in I didn't. It's whoever's in the chat. Yet you said the same. Right. Oh, Salady, thank you for going public. Yes, my bad. I was just trying to say. So my bad. But if I've, do you understand what I'm saying now? If I'm saying that, like Ashton and Sulady, like, does it make sense now?
Yeah, 100%. Yeah.
Okay, cool. 100%. Awesome. Okay. And thank you, Slade. Thank you. Okay, this is communication. All right. Yes. Did I say group therapy? Okay. Okay. No, and I'm totally kidding. Obviously, we all know that I'm the problem. Okay. Okay, so that's the answer to that one. So then letter B, straight up the answer to this is 100 hertz. Like, where we're just trying to test here that we know that, oh, wait, there's something in the chat. Oh, no. Oh, right. No, that's good. Oh, yeah, by the way, you both now, for the record, Ashton and Salini, you should submit points to Multiplayer Co-op, the portal that acknowledges collaboration among colleagues, right? Because you both just acknowledge each other's existence in a non-negative way. That's good enough to preserve this community. So there's a portal for that. So submit and get points. But okay, and there's also something in the chat. Okay. But now the answer to this next one is just like 1 hertz by definition. And someone asked me this in the chat as well. 1 hertz by definition is 1 cycle per second. So the answer to this one would literally be F would be 100 hertz. End of story. Like, it's just asking you to understand that. Okay. And then, so then the next answer, to get to the chase, to do this next one, the point is that T triple equal sign, if I can do the triple equal sign, T period is now asking for period. Well, that is necessarily the reciprocal, the multiplicative inverse of frequency. Period and frequency are by definition reciprocals of each other. So in other words, in this case, T equals 1 over 100, i.e. 1 over 100 cycles per second. 1 over 100 cycles per second. I'm not writing this very well because I'm like typing it, but in other words, 0.01 seconds per cycle. like if this thing, and that's the answer to that one, if this thing does 100 cycles every second, that means how many seconds does it take to do a cycle? Well, 100th of a second. Like like it's doing them really fast. It's doing 100 cycles every second. So it doesn't even require a full second for it to do a cycle. In fact, it only requires 100th of a second for it to do a full cycle. Like, all right, and to make sure we understand this, I'm going to say now in the chat, in the chat, just I'll wait till I have 3 people. If it takes me 5 seconds to run around, no, that's ridiculous. If it takes me 5 hours to run around the track, then how many laps around the track do I do every hour? If it takes me 5 hours to do 1 lap around the track, then how many laps per hour do I do? I'm going to wait till I get something. I'm going to say it again. If it takes me, so I'm taking the concept and I'm just like flipping it around now, but it's the same concept. And I'm switching from seconds to hours, just to make sure you get the concept. I see there's one thing in the chat, maybe there's things on the other chat too. I'm going to wait till there's 3 things in the chat, but I'll say it again. If it takes me 5 hours to run a lap around the track, then how many laps per hour am I running? And it's not meant to be a trick question, but your answer might, there's 2 things in the chat. I'm gonna wait for one more. It takes me 5 hours to run. There's 3 things in the chat. Awesome. All right, so 2 okay, cool. All right, I see. So there's what, yeah, the answer is 1/5 laps per hour. 1/5. If it takes me 5 hours to go around the track, then I'm doing 1 lap. Then I'm doing 1/5 of a lap every hour, which most of you said in the chat, which is great. And I'm going to move on in a second, but wait, let me just make sure. So I'm going to say to you, I'm going to ask you, I'm going to move on and say, we're actually making, good. Okay. Thank you, direct chat person. We're actually making progress here, I think. Raise your hand. If now, see when I just slightly changed 10 and made it well, all I did was change the the hours to seconds. Well, basically, I just like shrunk the numbers down to more reasonable. With this change, do you guys understand the question, this question 10 now? You give me electronic thumbs up if you're clear on question 10 with this revision and these answers. Cool. Oh, thank you, Remy. Okay, cool. Thank you, Ashton. Cool. Wait, is there other people? Thank you, Fatima. I see that I can't see everybody at once, but thank you, Sulady. Thank you, Jonathan. Thank you, Kayla. Okay, thank you. Okay, if that's the case, let me say to you, that question, is it going to be these exact numbers or this exact thing on your exam? No, I will tweak it some. But the tweak you had on the question before I just adjusted it, the difference was you had cycles per hour. I just changed it to cycles per second. So once you see how to do this per cycles per second, the point is there's 60 seconds in a minute and there's 60 minutes in an hour. So you would take all these numbers really and adjust them by 60 times 60. I'm not saying that's easy, but I'm saying the truth of the matter is that this is the fundamental basic version of the question. And then if you get this, then you can do a little twist on the exam, or you could practice, try a couple of different versions of this, but you could do a little twist on the exam. I think why people got thrown off is that the original time when you first got this question on a homework, it was sort of already in twist version, if that makes sense. So I think it like threw people's brains off, but I think you get it now. And if you just practice something like this a couple of times, I think you have it. So I'm going to move on. We're getting, we really are getting somewhere now. Okay. Yeah, and I'm gonna okay. Let me just clear my psychological plate here for a second. Well, yeah, all right. I think I'm gonna start banging the key thing for 11 the key thing to know for 11, but it's hard for me to write in this. The key thing to know for this problem is omega equals the square root of k over m. I'll say that again. Omega equals the square root of k over m. Now, in fact, let me pause. I'll give you answers in a second. Maybe that'll be the fastest thing to do. But and it's hard for me to write that because it's a square root and whatnot. But omega equals, yeah, I'm just thinking omega equals the square root of k over m. Now, I'm going to give you an answer in a second, but let me just also explain to you what, again, what's going on in this test. We're ultimately, well, we're the first part of the test was to make sure you sort of understand what theta means, what an angle is, especially when it's measured in radians, because then it turns out we have to take the cosine of these angles measured in radians. And it's like, what we're trying to drum in at the beginning of the test is like, because it really seems like a lot of geometry. I know that. It seems like a lot of trigonometry. I know that. It seems like a lot of abstract math. It just has to do with like weird things in a circle and like, who cares? I know that. What we're trying to do is build up just enough math from circles so that we can analyze cycles, right? I know I've said that a number of times. So we're trying to like understand angle theta measured in radians so that we have some understanding of what it means to take a cosine of the angle theta measured in radians, so that we can now look at these physical systems that are oscillating back and forth in the manner of a cosine, or oscillating back and forth in manners that are best mathematically predicted and expressed by cosines. In fact, let me pause for a second and say too, since so much of this, now we're getting to the cosine portion of this test, right? Or I mean, you were doing cosines like geometrically up in the early part of the test, but now we're trying to apply cosines to physics, right? And maybe I've never quite said this clearly before, but like if you always hold in your mind that cosine is the x coordinate of where you are on a circle, on a unit circle, and unit circle just means circle of radius 1, which again was all those early problems were trying to just say, look, if we could all the math of a circle always applies no matter how big the circle is. That's our beautiful revelation, that it doesn't matter how big a circle is, pi is pi is pi. Like the ratio of the circumference to the radius is always the same. So no matter how big a circle is, the math is always the same. So then when we all decide, let's all from now on just picture circles of radius 1, because the math is easiest when the radius is 1, and we know the math is going to work the same for all the other circles. So from here on in, we're always picturing circles of radius 1, and we call that the unit circle, right? So then we say, wherever you are on the unit circle, your x coordinate, however far out you are, we call that cosine. And however up you are, we call that sine. And that's all that cosine and sine are, is how far out you are on the circle and how far up you are. So now think about this for a second. If you go round and around in a circle, if you just keep going round and around in a circle, of course, your cosine value is going like in a cycle. Your cosine value starts at 1, and then it gets smaller to 0, and then it goes to -1, then it goes back to 0, then it goes to 1 again, then it goes to 0, then it goes to -1, then it goes to 0, then it goes back to 1 again, right? And sines do the same thing. But the point is now cosine is just a way of tracking, of using circle math to track something that's going back and forth, right? Cosine, where you are in a circle, cosine tracks you as though you were just going back and forth, because it's just tracking your x coordinate on that circle. So cosine is just our mathematical way of tracking how far out you are as you come in, and then you go out again, and then you come in, and then you go out again, and then you come in, like a mass on a spring. So a cosine from this circle thing is what we use to describe a mass on a spring going out and in and out and in, just like your x coordinate on a circle. If you're going round and round a circle, your x coordinate will go in and out, right? So we get to cosines. Now what we're saying by 12 is that the rate at which you do that, the angular frequency, the radians per second, the number of times you're completing cycles per second, It actually comes from physics. Like if we're talking about a physical system, if we're talking about a mass on a spring, then it turns out the sort of wild revelation, and it is a revelation, the discovery is that the rate that you do this back, if you're a mass on a spring, the rate that you do this back and forth is totally determined by the spring stiffness and the heaviness of the mass. Once you know how heavy the thing is and how tight the spring is, you'll know the rate at which it's going back and forth and back and forth and back and forth. That's what we mean by saying, and please again, write this down because I can't write in the sheet. Right, omega equals square root of K over M. And in fact, I'm going to encourage you further to please write in English. Please write in English. We've said this before a million times, but here's the point of this whole thing. The frequency of a harmonic oscillator is entirely determined by the oscillator parameters. I'll say it again. But again, the equation that we're talking about here is omega equals square root of K over M. The square root of K divided by M. Omega equals square root of K divided by M. K is spring stiffness, M is mass on spring, right? Now we're going to plug and chug with that equation in a minute. But the power of that equation, the physical implications of it are that omega, angular frequency, rate of oscillation, is entirely determined by how stiff the spring is and how heavy the mass is. The frequency of an oscillator, frequency of a harmonic oscillator is entirely determined by the oscillator parameters. What are parameters? Parameters are constant material properties of the system. So we're saying if you measure the ingredients of the system, if you measure how stiff the spring is and how heavy the mass is, before you even start doing anything, you'll automatically already know how rapidly, how quickly, how frequently the thing will go back and forth. The harmonic oscillator frequency is determined by parameters. Now, here's one more, and I know I said that a couple of times, and if you want to tell me in the chat to repeat it, I will. But here's what, as opposed to what, you might say, or like, duh, or like, what else could it be? Or like, what are you even saying? I'm saying the frequency of a harmonic oscillator, is independent of amplitude. Independent of amplitude. I'm reminding you, like we said this before, but the power of this whole idea is once you set up a mass on a spring and you know what mass you're talking about and you know what spring you're talking about, the thing is going to go back and forth at a fixed rate that you can't do anything about. It doesn't matter how you set it up. It doesn't matter if you start the mass all the way over here and then it go wah, 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 or you start the mass over here and then it go wah, 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 wah. All the wah-wahs will take the same amount of time. They will be the same number per unit time. It's going to be a tick-tock, reliable clock, no matter what you have it do in space. This is the importance of omega equals square root of K over M. It's going to come back again to haunt us at the end of this, or to thrill us at the end of this whole exam. But I just want you to know that now we're transitioning. We went from the raw, I know tedious more thing of theta. We went from theta to then cosines of theta. Now we're relating cosines of theta to the physical material world, where the cosine of theta, the cosine of omega t, is determined by physical properties in the physical world, namely omega equals the square root of K over M. Therefore, now I know I'm like yelling now. I mean, but I'm just going to try to tell you the answers to this or whatever to this one, because now it gets into the physics point. So the mass is held at rest at 40 centimeters from the spring's equilibrium. And also going to tell you, if you're taking this exam, or when you are, you're going to draw me a diagram here. Like, I'm not doing it right now. Partly I'm running out of time. Partly like I'm, my body's like triple tasking on this PDF and it's like degenerating. But always remember, you always start off with a diagram. You start with a diagram and you label it and you write what is the question. I mean, you write what the question is. Then you're going to GDP. And it says, so it gives, and you're going to label the facts. Okay, so here are all the facts right here on the screen. So our goal is to know precisely where the mass will be at any given instant of time. Okay, assume that this oscillator can be described by x equals a cosine omega t. Right, yeah. Right, so find the value for omega. Okay, first of all, omega equals square root of K over M, like I just said. So omega equals a square root of 4,000 divided by 8. right? 4,000. Oh, that's inconvenient, but okay. So it's 4,000 divided by 8. So that's 500. On your test, I'll try to make it so that it works out to be a perfect square. I think this is a mistake that I didn't do. I mean, it's still valid, but it's like annoying. So it's 4,000 divided by 8. So that's 500. So your omega is the square root of 500, which is an annoying number, but it's a real number, but it's a fine number. I mean, it is a number. So the square root of 500. Okay, so like 22.4. So you'll write, and I'm starting to run out of time here, so I'm getting a little bit. You're going to write omega equals approximately. You're going to write that omega equals approximately, and it is approximate because I'm chopping off digits from the calculator, right? And what did I just say? 22.3, I think, radians per second. And you're going to show all work. I'm just giving you answers here, you know, to help, to try to help. But you're going to show all work, please, 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 when you do this. Okay, then what's the value for A? That's the amplitude. That's where the thing, that's the farthest position that it ever is from equilibrium. It's where it was at rest initially from equilibrium. So the answer in this case is 40 centimeters. And that's like not approximate because we were just told, okay. Find T, the period for this oscillator. The way to do this. Well, let me do some things, but not others. I don't know, probably because of the color or the font. Sorry. This is getting so stupid. No, I don't know why it's all right. I'm saying that, right? That's a definition. Omega equals 2 pi over T. Just like the same reason as omega equals 2 pi times F. Like look back in the earlier part of the sheet and you'll see the whole, again, it comes down to that. And I see there's something in the chat. I'll check that out in a second. But there's omega is radians per second. There's 2 pi radians in every cycle and T. So anyway, so I do that. Therefore, T equals 2 pi over omega. Right. So I would say that T is approximately equal, and I will look in the chat in 1 sec. Where'd it go? Oh, so T is approximately equal to 6.28 divided by 22.3. So like 0.282, okay. Okay. Okay, that's how you do that. I'm going to pause for a second because there is a couple of things in the chat. Oh, well, for A1, I did. It's hard for me. All right, I hear you, Remy, on writing out the math for A1. The reason that's hard is because that's the square root thing, and that I do not know how to do in this. I can't really do the square root. All right, I'll try. Hold on. All right, let me very quickly, and then I'm gonna have to pause. I am watching the time, and there's well, wait. I guess that's what Jake did. Okay, thank you, Jake. I see. Yes, it is what Jake did there. Honestly, that's about as good as I could do on the board, but it's right. It's a square root of 4,000 over 8. And square root of 4,000 over 8 is 500. I can't really do much better than that. He's saying, I mean, but I agree with him. It's square root of 4,000 over 8. And 4,000 over 8 is 500. So it's a square root of 5,000 of 500. And so you get about 22.3. Yeah, I'm going to pause for a second. No, I'm not I'm going to pause because I want to look at the time situation here. Well, okay, I can go a little bit more. Okay. I think some of us have talked about this before, but now, precisely where will the mass be located as measured from equilibrium? I won't answer all of these, but I'll give you a sense of how to do it. Like when t equals 0, well, the way to do all these at worst is you just plug in the value of t into that cosine equation, right? Oh, there's stuff in the chat. Nice. Oh, look, he totally did. That's great. That's great. And that thing that Jake's saying about the units goes back to how we began this whole class today. Like, someone put it, I think it was in the direct chat, so I'm not going to say the name, but someone asked way at the beginning, what's the deal with radians? Or maybe that was another class. I don't, but yes, what Jake is saying is right, and cool and good. And it's all about the fact that radians aren't technically a unit, so they cancel. So they float around in a funny way. But that's very good. When t equals, so I'll do this first one. When t equals 0, x equals a cosine of omega times 0. So x equals a times cosine of 0. And we want you to know at this point, cosine of 0, that's 0 over here on the unit circle, that's 1. So it equals like a times 1, it equals a. So the answer to that very first one is a. But if you think about it, that makes sense. I mean, hopefully you should see that that makes sense. Like I just plugged in, but right at the beginning at this experiment, where is the mass? It's at the amplitude position, because that's what amplitude position means. It's where the mass started off and where the mass never gets any farther than. Okay, to do the next one, you could plug in 1 second and go from there. And for the next one, you can plug in 5 seconds into the same exact equation. But now when it starts asking in question 4, like, well, what about when t equals t? Like, well, then it's asking, what about when the thing has gone through 1 full cycle, when the amount of time is the amount of time for 1 full cycle? Well, if you understand the definition of cycle, then you don't have to plug. I mean, you could keep plugging in. You could plug in for all of these as long as you always realize that t, like where my cursor is right now, t equals 2 pi over omega. You could just keep plugging in 2 pi over omega into the equation each time, and the omegas will cancel out, and you'll get proper, correct answers. Or you could think about it intuitively. When a full cycle of time has gone by, that means a full cycle has gone by. So the mass is back to where it started. The answer to 4, I'm just telling you now, I'm going to stop writing for a minute because we have to resolve some things. The answer to 4 is x equals a again. And question 5 asks the exact same question again by mistake. It's the same question, so it's the same answer, x equals a again. The answer to 6, when t equals t over 2, that means when it's a half a cycle has gone by. That means the answer is negative a, when the mass is on the other side, when it's gone there, but it hasn't come back yet. Okay, and 7, if you just plug in and you do the cancellations, you'll see what happens in 7. In D, at the end, the only thing they change is A, and they ask for the new period of oscillation. I'm telling you right now, the answer for the new period is that it doesn't change at all. like the new period is the same as the old period. It's whatever it's 0.282 seconds. What it's trying to ask you here, was trying to make sure you know, is exactly what I was just like screaming a minute ago, that the point of an harmonic oscillator is that its frequency does not depend on its amplitude. There, and period is just the reciprocal of frequency. So if its frequency does not depend on amplitude, period does not depend on amplitude. You can change the amplitude and it doesn't change the period. That's the beauty, the nature, the character of a harmonic oscillator. A harmonic oscillator is a true clock. It keeps time even when you change things in space. So the answer to 12 is it doesn't change the period. The period is the same as above. Okay, so we're almost, so now I know we haven't done, now I haven't done every single thing here, but we've done a lot. And I think you're in a position to figure out all the rest on your own. The two, and we have 15 minutes. Now bear with me. I know this has been a long class as usual. I think it feels like it's been productive for many people. I know we're all taking turns being crazy. Like I know at one moment it's productive for one person, and another person wants to gouge their eyes out, and another point it's productive for a different person, and I want to gouge my eyes out, whatever. But hopefully in the end we've all gotten something out of this. But there's still 15 minutes, and this may be the most important 15 minutes. I ask you to bear with me here. I want to say a couple things about this question 4 for sure. And I want to say something about the test itself. So, all right, so quick. So first of all, on the test. Wait, okay, no, first of all, on this question 4 is the free response question. It's really where you are asked to put this all together in your way, where you, like for some of you, it will be the easiest question because you can be the most creative, and you are the least boxed in to exact right answers and exact formulas. But for some of you, it'll be the hardest because it's the most open-ended and you're not sure what to do or what to expect. The first thing I want to say about this last question 4 is watch last week's video. Last week's video, or certainly the end of it, is all about this question. Last week's video. And I will try, I've also done a thing like this in some other classes like Physics 204. Even if I don't remember to literally post them in your Google Classroom, I will tell you right now that if you go to the Physics YouTube channel, if you go to my YouTube channel, if you go to the playlist for Physics 204 for this semester, I mean, yeah, there's like more advanced, there's other things that go on in that class. It's a different class, but but you will find videos from the last 2 are literally titled this thing, like they're titled phase staggered harmonic oscillator or collection of phase staggered oscillators, or whatever. And because they also have a question like this very similar on one of their exams. The rest of their exam is very different, to be honest, and it's very calculus-y and all that. But they have this question too on their exam. And there's a whole video on just this that I'll try to remember to cross-link to your Google Classroom. But I'm pleading with you right now, please take a note of the fact that if you just go to the YouTube channel and go to the 204 playlist, there's a whole video that walks you through exactly this, okay? And what this is ultimately about is the punchline of all this material. Without going too crazy right now, what I want to say, because I know how sloggy this is, but I want you to see there's a reason for all this. Like, we think it's worth it in the end for you to get out from under these cosines and these radians and everything, which give everybody in life trouble. What we're trying to say is that if in the early questions of this exam, if you can unearth cosines and you can unearth, if you can unearth thetas and unearth radians and then unearth cosines and like get a picture of what cosine and finally put them all together to picture the math of one one particle oscillating back and forth in time. I'm not saying it's the most interesting thing in the world, but it is a fundamental thing in the world, something going back and forth in time. What we're ultimately trying to say, like in the last class video, in your last few labs, and in this other video that you'll find on YouTube, what we're trying to say is now, the purpose of all of this is that if you take a bunch of these objects, oscillating in time, a bunch of these time oscillators, and then you arrange them so that they're all in an oscillation in space. We're saying again, and I want you to be able to work this out in detail in your way with colors and pictures and whatnot. But we're saying if you take a bunch of objects that oscillate co-sinusoidally in time, and then you stagger them in space so that this one starts, and then this one starts, and then this one starts, so that they form a cosine in space. If you have cosine oscillations in time arranged in a cosine oscillation of space, then what you have is a wave pulse that flows, that propagates through space from here to here. You have a bunch of material objects going up and down little vertical axes, but all together they create something that flows along a horizontal axis. If you have a bunch of pieces of metal, it's just like the Yankee Stadium thing. You have a bunch of human beings, and each human being goes up, down, then up, down, then up, down. Then something flows through Yankee Stadium from left to right, and everybody sees it on all the TV cameras, right? A bunch of human beings can make a human wave, and it's the real thing. Like something absolutely flows from left to right, and it's really cool and it's really fun because we all know the only thing moving is human beings, but not one single human being moves from left to right. So the thing that flows from left to right is an immaterial entity that we call a wave pulse. And it came about when a bunch of time oscillators gathered themselves into a space oscillation. You got to understand oscillation to understand how waves work. But once you understand oscillation, you can ultimately understand the physics of things moving immaterially through space. That's what question 4 is asking you to put together. We're trying to put all these oscillations together to actually make the motion of an unthingy thing. That's really the heart of this course. It's the core of this course, is to ultimately see how material objects in space and time can come together to make a motion that is not material. That's the punchline of question 4. That's what you're trying to show in question 4. Again, to really, and we want you to do it your way, but we want you to cover pictures and math and words. So you'll have to watch the videos again, and you have to sit down and practice, like write a rough draft of this thing, and it'll start making sense to you as you write it. I'm not saying it makes all sense to you right now. We're not, but I am saying that the exercise of going through this will cause you to realize what we've been trying to get at in lab 3 and lab 4 in particular. Okay, that's what question 4 is about. You'll watch the videos. But now, and I do see this, but there's 8 minutes more. I got to say, hold on, there's something in the chat. Oh, okay, no problem. Oh, okay. Yes, I'm sorry. I missed. Okay, I think she's gone already. But yeah. Okay. Now with 8 minutes more, we'll say about the test in general. On the test, as I said at the beginning, you're going to give me lots of blank sheets of paper where you are, like, I tried to give you answers here. I'm trying to talk a lot, and you talk a lot, and I know that. But what I want you on your exam is I want you to talk a lot. I mean, I don't want to be like me, but your job is it's not just to give us answers. Like, your test is going to look very similar to this, like shorter, clearer, okay, less crazy, but super similar. There's going to be a lot of questions on your test, which actually I don't even change the numbers. There are going to be a lot of questions on your test that are actually identical to this. Your job isn't just to spit back the answers. I already know that you know that I know that we have the answers. Your job is to show me the work, to show me where the answers come from, to do the 5-step method, to walk me through. And the easier any little part is, or the more you think it's obvious, or that we've gone over it a million times now, go to town. You're here to derive the answers, to prove that you understand the answers, and to give me as much process as you can. Once you give me a process for one, if the rest of a bunch of questions are redundant, then you could say C above, C above, C above, whatever, okay? But your job is to show me that you understand these concepts. They are concepts. That's why we keep going through them and through them and through them. You get them when you get them. You don't get them until you get them. And we all know that. And a lot of us won't get these concepts until we actually sit down to try to write this out. Now, wait, and I know I have 7 minutes. Yeah, now, Oh, no, this class will definitely be posted. Wait, certainly this class will be posted. All your prior classes have been posted. Yes, this class recording will definitely be posted for sure. Yes, please. And and the last one is particularly important for question 4. And you should look at the other YouTubes. Now, Kayla's question, of course, is the ultimate question. We have 6 more minutes. Okay, good. We have 6 more minutes for me to say one more. The most important thing of all is like, when is this midterm, right? Like Kayla's question, thank you. Yeah, when is this midterm? She asks, is it next Monday? Well, here, yes and no. Here, hopefully you're going to find this to be good news. Let me pause for 1 second. You have school next Monday. You have lab next Monday, but you don't have class next Wednesday. Today is, hold on, today is Wednesday. About to be interrupted at a crucial moment too, God. So the quick answer is, so the quick answer to Kayla's question, we do have to resolve this finally right now about exactly when the midterm is, but there's one thing that maybe is not clear to all of you, and I hope that you'll find this to be good news. Everything I'm saying about what I want you to do in this midterm and show me all the work and all this stuff, you're going to do it at home. It's not an in-class exam. It's a take-home exam. That has some disadvantages, but largely, hopefully, that will be advantageous to most of you. This is a take-home exam. And well, let me start with that. Oh, okay, you did know that. Okay. Oh, okay. No, okay, good, fine. Okay, so you did know that. All right, so it's a take-home exam. So the question is when the exam is going to be due, and you're going to have like 5, usually we give like 4 days from when it's posted to when it's due. So it is true. My ideal, I'll tell you right now, we do want to get this thing out of the way, and we don't want it to be too close to the final exam, but I also don't, and I don't really want to ruin your break or anything like that. So my proposal is what I think would be best, and I guess I'll say this strongly. I think it would be best if this thing were due. I'm sorry. Today's Wednesday. If I post this tomorrow night by 8:00 p.m., if I post it tomorrow night by 8:00 p.m., I want to we have 3 minutes now. I think it would be ideal and best if this thing were out of the way by 4:20 or 4:30 Monday. But if I post it by 8 p.m. tomorrow night, Thursday night, so you have Thursday night, Friday night, Saturday night, Sunday, and Monday to do it. I mean, this is like a dangerous question for me to ask, but I'm strongly asserting that I think that would be best. Oh, thank you. That's very honest. I think, and here's what way to ask it very quickly, since we have 3 minutes. If you have a strong conflict or a strong personal objection or some strong reason why that would actually really be a problem, can you put in the private chat, please? I'm going to say that. So what I'm shooting for, what I want to say is it gets posted tomorrow night by 8:00, maybe possibly earlier, but no later than 8:00 p.m. And then it's due back right before lab starts, so that it's out of the way and like there's no, so it's done and turned in. Right. Okay. I appreciate that. Okay. And I will post this information in the Google Classroom when we're done, like just to remind everybody. But okay, and I appreciate your attitude on this. Because, and I'm going to take it. I mean, again, there's like 1 more minute. Someone could, and if people turn out that they have personal objections or a personal conflict that they're not realizing right now, they will write me personally, and we'll like, especially if you have to go to a funeral or something like that, we'll make personal accommodations if need be. And same thing with the final exam. But if this is what we're saying with the group, with 2 minutes left, we're going to say I'm going to post it tomorrow night by 8 p.m. you turn it in right before you come into lab, and then you come into lab, and you got to come to lab because otherwise it looks to your classmates like you're still doing the exam, and then they think that's unfair, and they're right, and they think I'm a pusher. And one place I'm not a pushover about is exams. If you go into any situation where you see that it's going to be late or you anticipate a problem, you're going to write me or text me in advance, and we'll see what we can do. But you can't. But other than that, you just got to turn the thing in by 4:30 into Google Classroom. It'll be posted in Google Classroom, and then you walk into lab and show your colleagues that you're not cutting corners. Now, here's the last thing I'll say though, since it's the last time I'll see you before then. I don't know if we have one more minute, and you're going to want to hear this. I don't know if Mercedes made this clear or not. It's take home, it's untimed, and as far as resources, like, can you use your notes? Yes. Can you use the internet? Yes. Wait a minute. Can you talk to other colleagues? Yes. It's an open universe exam. And I mean that seriously. Sometimes that sounds like a gift to people. It sort of is, but it sort of is not. I want to make it clear with the 1 minute left. I'm going to post this thing Thursday night. You're going to take it. You're going to help each other as much as you freaking want. And I'm going to know that you are. I'm going to encourage you to. You can help each other even while the exam is rolling. You can't get help from me, but you can get help from each other. You can get help from your uncle or your aunt who just won a Nobel Prize in physics. You can go all over the web and check out Khan Academy and all my videos or whatever, blah, blah, blah. I'm not kidding. It's right. Well, okay, good. I'm glad Remy just said that. Let's quote Remy on that. Don't blow your brains out though. Don't blame. But no, and I do mean it. And it's not a trick. The only catch or the only trick of it, and it's because in physics, exams are meant to get you to know the material, not to catch you, not to find out that you didn't know. We're trying to force you to know it. We're trying to leave you no option but to understand this material by the end. So also bear with me for one more minute. I know we're just about done, but this is an important thing to hear if you've never done. And this is the same thing with the final. It is open universe. I want you to help each other. I want you to help each other and all of that. Help each other understand, help each other get the concepts. And at the end, you don't have to quote and say, Remy, help me with this part. It's not about physics is physics. You don't have to, or say, I got this from Khan Academy. No. But the one standard is you got to remember that I know that you've done that. We all know it's a fully open exam. So what I'm grading on, what I'm looking for is a full presentation that convinces me that you understand what you have written down. The only thing that would constitute cheating is to write things down that you don't understand. And believe me, I do know the difference. Your job is to convince me with all of that you write and all what you present in your colors and your pictures and your annotations. You're trying to present to me a full understanding of this material. You're showing me that you've learned it, even if you learned it 1 minute before you wrote that stuff down. Even if Ashton is sitting there holding your hand while you're doing it, I'm just using as an example. I don't care when you came to understand it, but by the time it goes on paper, you're showing me, you're walking me through the travels of your mind and showing me that you actually understand it. So the one real thing I would highly encourage is do a rough draft and then make your final copy, an actual final copy where you actually put it all together and give me a document that you are proud of, that I will want to read, that I will look at me like, that is so pretty. Like, do it, right? Teach me better than I taught you, so to speak. That's the goal. Definitely help each other. Definitely ask people questions. Definitely go online. Definitely walk back and, okay, I see I'm over time. But it is absolutely open universe because we want you to understand it by the time you're done. But that's what you're proving to us. Don't just give me answers. Remember, that's the way I'll grade it. I'm looking for process and presentation. It is a presentation. It's like a research report or whatever, but you're showing me that you, okay, and that's, if you have any issue with the timing, you'll contact me personally, like before Monday, and you'll say, something's going on, there's a family emergency, I need more, and we'll work together individually. And that applies to all of you, so it's fair. And the same thing could happen on the final exam. But if you don't contact me, I'll assume that you'll have a full presentation of gorgeous, clear to follow work that I can grade without even looking at the original exam. The more you understand something, the more you explain it. And the less you understand something, the less you lie about it. Okay, is that And yes, use it. Oh, thank you, Kat. Yes, use the 5-step process. That's the whole point of it, right? Even the little exercises that you think are just little exercisey, then the first time you do a little exercise, walk me through the 5-step process. Say anything that you understand about it. The more you remember, the more that you think is important. Show me that you've been taking this class. Then, if it's a repeated exercise, again, you don't have to do the whole 5 steps again. You can always say, see above, see above. But yeah, it's all about the 5-step process. You can literally even label the margins like step 1. Here's my step 1. Here's my step 2. It'll force me to have to give you a good grade if you do that. If you literally should, because that's how I grade. That's the rubric, is that like you get 2 points for step 1, you get 2 points for step 2, like literally. It's not about final answers. It's about the process. So if you walk me through the process and show me that's what you're doing, you're literally grading it for me. I mean, if you see what I'm saying. Okay, wait, sorry. I know I'm going a little over time, but so we have a deal. Does that make sense? And I mean it. I want you to work together. We want you to help each other. We want you all to get 100 by the end. It's designed. It's not actually a gift. I mean, it is, but I mean, whatever. It's designed so that if you actually try, you can understand all this physics by the end and everybody can be happy and go home legitimately. So speaking of going home, I'll stay for a minute. If there's any personal question, if there's any individual, I'll stay for a minute. But yes, I'll post this recording, blah, blah, blah. But you've been very, very patient as always. You are a wonderful crowd of people that deserve, if you keep doing what you're doing, you will all get good grades, honestly. I mean, but okay, so I'll shut up. I'm going to turn this off. I'm going to stop the screen, but I'll stay until the last person. But have a nice night. Sorry. Have a nice night. And don't blow your brains out, please. Yes, have a good night. Oh, thank you, Catherine. Okay, thank you. Okay, thank you. Oh, great. Thanks. Okay, great. Thank you, Salady. Thank you. I've turned dark. Have I been dark this whole time? Oh my God, that's so weird. Okay. Thank you, Eugene. Thank you, Nicole. Bye. Bye. Okay. Whoa.